Hello friends, myself R.D. Mahajan, Assistant Professor, Marathwada Institute of Technology, Aurangabad, presenting my next video on the topic Inverse Laplace Transform by partial fraction method. There are three different cases for it. Case first, when factors are real and different. Second case, when factors are real and repeated. And the third case, when factors are quadratic. Therefore, depending upon the nature of that factor, we have to apply the method. I will discuss the first case. When factors are real and different. By solving this example first, find inverse Laplace of 1 upon s plus 1, s plus 2. Find the inverse of this. Here in denominator we have two factors, s plus 1 and s plus 2. Both are real and different. Therefore, it becomes case 1 that factors are real and different. And therefore, here factors are real and different. Therefore, using partial fraction method, or technique, we have that term 1 upon s plus 1 and s plus 2 is equals to, here factors are real and different, and whenever factors are real and different, a way to find partial fraction is a upon first factor and b upon second factor. And when we can apply partial fraction, if it is a proper fraction. Proper fraction means the degree of numerator must be less than degree of denominator. Here the degree of numerator term is 0 and degree of denominator term is 2. 0 is less than 2, that's why it is proper fraction. And as it is proper fraction, we can perform partial fraction. Then finding LCM, therefore we have 1 is equals to, cross multiplying it, a into s plus 2 and plus b into s plus 1. We call this as equation 1, this as equation 2. And then to find a, put s plus 1 equals to 0, means it implies s is equals to minus 1 in equation 2, and therefore we get 1 is equals to a into minus 1 plus 2, we get a is equals to, therefore this one is 1 into a is equals to 1, therefore we get a is equals to 1. And to find b, put that s plus 2 is equals to 0. It implies s is equals to minus 2 in equation 2. We get, therefore 1 is equals to this becomes 0, and we get here b into minus 2 plus 1, we get this one as minus 1, therefore minus b is equals to 1. It implies b is equals to minus 1. Put these values in equation 1. Put it in 1, we get. Therefore, that equation 1 becomes a is 1 upon s plus 1, b is minus 1 upon s plus 2, and then taking inverse on both sides, therefore inverse Laplace of 1 upon s plus 1 s plus 2 is equals to inverse of this term, and taking individual inverse of the first term 1 upon s plus 1 minus inverse of second term, and then it is equals to applying standard result, s plus a, its inverse is e raised to minus at, therefore it is e raised to minus at, a is here 1, therefore e raised to minus t, minus inverse of this is e raised to minus 2t, and that is inverse of this function is f of t. Therefore, inverse of this by partial fraction method is e raised to minus t minus e raised to minus 2t as the answer. Second, find inverse Laplace of s upon s minus 1, s minus 2 and s minus 3. Here the degree of numerator term is 1 and degree of denominator term is 3. 1 less than 3, and that's why it is a proper fraction. And as it is proper fraction, we can use partial fraction method. Here 3 factors: first s minus 1, second s minus 2, third s minus 3. All are real and different. Therefore, case 1. Here factors are real and different. Therefore, using partial fraction technique, we can write that term s upon s minus 1, s minus 2 and s minus 3 as a upon first factor, b upon second factor and c upon third factor. Okay, and then by finding LCM we can obtain the values of a, b, c, that is or another way to find the values of a, b, c, we can get the value of a as s upon s minus 2, s minus 3, means neglecting the term below a, s minus 1 from this, therefore taking the remaining as s minus 2, s minus 3, and its value at s is equals to, equating this to 0, we get s is equals to 1, and therefore it is equals to, put the value of s is equals to 1 here, we get 1 upon 1 minus 2 and 1 minus 3, and that is equals to 1 upon this one is minus 1 into minus 2, minus 1 minus 2, and that value is 1 by 2. This is the value of A. Then B we can get as, neglecting this second element s minus 2 which is below B, and therefore s upon s minus 1, s minus 3 at s is equals to 2, equating this to 0, we get s is equals to 2, and therefore it is equals to, therefore it is 2 divided by 2 minus 1 we get 1, and 2 minus 3 we get minus 1, therefore 2 upon minus 1 we get that value as minus 2. Okay, and then C is equals to, neglecting this third which is below C, and therefore it is s upon s minus 1, s minus 2 at s is equals to 3, equating this term to 0, we get s is equals to 3, and therefore we get this value as C is equals to, s is 3 here, 3 minus 1 we get 2, and 3 minus 2 we get 1, and therefore if we simplify it, it is 3 by 2. Substituting these values in equation 1 we get, and therefore it is, equation 1 becomes A is 1 by 2 divided by s minus 1, B is minus 2 upon s minus 2, and C is, it is 3 by 2 divided by s minus 3. Okay, and then taking inverse on both sides, therefore inverse Laplace of s divided by s minus 1, s minus 2, s minus 3 is equals to inverse of right hand side term, and taking individual inverse, 1 by 2 constant outside, inverse Laplace of 1 upon s minus 1 minus 2 inverse Laplace of 1 upon s minus 2 and plus 3 by 2 inverse Laplace of 1 upon s minus 3, and therefore it is equals to 1 by 2. Again applying this standard result, inverse of 1 upon s minus 1 is e raised to at, a is a 1, therefore e raised to t minus 2. Inverse of this again by standard result, e raised to 2t and plus 3 by 2. Inverse of this again by using the same result, it is e raised to at, a is a 3, and inverse of this f bar of s, if we call this as f bar of s, is f of t. This is the required inverse by partial fraction method. Here all factors are real and different. We can find like this. Find inverse Laplace of 2s square minus 4 divided by s plus 1 s minus 2 s minus 3. Okay, here the degree of numerator term is 2 s square and degree of denominator term s into s 3, and as 2 is less than 3 it is a proper fraction, and as it is proper fraction we can apply partial fraction technique or method, and therefore here factors are real and different or distinct. Means case 1, and therefore using partial fraction method, we get this f bar of s 2s square minus 4 divided by s plus 1 s minus 2 and s minus 3 as all factors are real and different. Therefore applying the technique, a upon first factor, b upon second factor and c upon third factor. And we call this as equation 1. And then applying the technique either by finding LCM or by finding values directly. A shortcut method. I am finding directly. We get a is equals to neglecting this term s plus 1 from this denominator term, and we get a is equals to 2s square minus 4 divided by s minus 2 s minus 3 at s is equals to equating this to 0, we get s plus 1 equals to 0, means s is equals to minus 1, and if you put that value here we get 2 minus 1 square minus 4 divided by minus 1 minus 2 and minus 1 minus 3, we get it is equals to this one is 1, 2 2 1 2 minus 4 minus 1 minus 2, it is minus 3, minus 1 minus 3 minus 4, and therefore that value is 2 minus 4 is minus 2, minus 3 4s are minus minus plus 12, and therefore that value is minus 1 by 6. This is the value of A. Then we find B as this time neglecting this term below it, that is s minus 2. From this we get 2s square minus 4 divided by s plus 1 s minus 3 at s is equals to, equating this to 0, we get s is equals to 2, and therefore it is equals to 2 into 2 square, I will write down directly, 2 square as 4 minus 4 divided by 2 plus 1 we get 3, and 2 minus 3 we get minus 1, and therefore it is equals to, yes, 2 4s are 8, 8 minus 4 we get 4 upon minus 3, therefore that value is minus 4 by 3. And then C last, neglecting this s minus 3 from this, we get remaining terms as 2s square minus 4 divided by s plus 1 s minus 2, and therefore its value at s is equals to, equating this to 0, we get s is equals to 3, and then it is equals to 2 into 3 square, 3 square we get 9 minus 4 divided by 3 plus 1 we get 4, and 3 minus 2 we get 1, and therefore it is equals to 18 minus 4, 18 minus 4 we get 14 upon 4. Yes, dividing by 2, we get 7 2s are 14 and 2 2s are 4. Therefore, that value in simplified form is 7 by 2. Therefore, substitute the values of A, B, C in equation 1. Equation 1 becomes, therefore it is equals to, the value of A is minus 1 by 6 divided by s plus 1. The value of B is minus 4 by 3 divided by s minus 2, and the value of C is 7 by 2. Therefore 7 by 2 divided by s minus 3. Okay, and then taking inverse on both sides, therefore inverse Laplace of 2s square minus 4 divided by s plus 1 s minus 2 and s minus 3, it is equals to inverse of this right hand side term, taking individual inverse of the first, second and third. Therefore minus 1 by 6 constant, inverse Laplace of 1 upon s plus 1 minus 4 by 3 inverse Laplace of second term and plus 7 by 2 inverse Laplace of 1 upon s minus 3, and therefore it is equals to minus 1 by 6 as it is, 1 upon s plus a, using the standard result, it is e raised to minus 80, a is there 1, Therefore, e raised to minus t minus 4 by 3. Again same result, inverse of 1 upon s minus 2 is e raised to 2t, a is here 2, and plus 7 by 2, inverse of this by same result, e raised to 80, a is here 3, and inverse of this f bar of s is f of t, and therefore this is the required answer or required inverse Laplace transform. Therefore, with the help of these three simple examples, I have explained how we can obtain inverse by partial fraction method when factors are real and different. In my next video, I will discuss the second case when factors are real and repeated. If you are watching my videos, please like it, share it, as well as subscribe my channel for latest update. Thank you. Thank you.